right. Second law of thermodynamics. Summarize it for me.
The second law of thermodynamics can be stated in many ways. Heat of itself never flows from a cold object to a hot object. And then the second law also says no heat engine can convert all the heat supplied into a mechanical engine.
Good. So there's two parts to this. So the first part is heat. So heat never goes from cold to hot. So of itself means naturally. So it never naturally goes from cold to hot. It always goes from hot to cold. And then the second part is this. So it can't convert. So no engine can convert all heat. So you can't ever do all of the energy. You can't ever convert all of it into energy, into work.
Well, what if I convert all energy?
To do all of it, it has to be really, really, really slow. Like really slow. And it has to be incredibly insulated. So there is something that does this. It's called a Carnot engine. It's the most fuel efficient, most efficient engine that you can make. It's incredibly efficient. One stroke takes like, I forget how long it takes. It takes like 15 minutes to do like one stroke. Whereas your cars run like hundreds to thousands of strokes a minute. Whereas this one takes like forever to do one. So it's not practical. It's not practical.
Okay.
Yes.
So hypothetically, do our cars go faster in the winter?
Yes. So not hypothetically. Your cars are more efficient. Not faster. They're more efficient in the winter. They're more efficient in the winter. Yep.
Yeah, I mean, they are faster when there's ice on the road.
That's right. When you're sliding all over the place. Good. So second law of thermodynamics, heat never goes. So this is the main part. The main part of the second law is heat goes from hot to cold, not from cold to hot. And the other part that's helpful too is this idea: heat never is converted all of the energy. It never converts everything. So I'll explain kind of the shorthand of the three laws when we get to the end here. But that's part of it. Okay. All right. Question 1.
How does a heat engine work? And the answer was heat flows out of a high temperature reservoir and into a low temperature one.
Good. So how does a heat engine work? So heat engines work by heat going out of something that's high temperature into something that's low temperature. A good example of this is your car. So your car goes from high temperature inside the engine to low temperature outside the exhaust into the air. So it's just transfer of heat. And because heat naturally goes from hot to cold, this is how we do work. We do work by naturally transferring energy from high temperature to low temperature. So you can see how these things are kind of going together. We have to know how the temperature works in order to use it. And then we know that energy that is created has to be transferred to somewhere. Okay? And then we know where that somewhere is. It goes from high temp to low temp. Yeah.
So say you have a cold air intake, right?
Yeah.
Cold air goes in.
Yeah.
You said it doesn't go from cold to hot. It was hot.
Yeah, so the air comes into the engine, then it's combusted. That's when it becomes high temperature. But you have to do the combustion in order to get the high temperature. And then, if you're wanting, so now it's high temperature, what happens? Well, it wants to go to low temperature, so it expands, pushes the piston out of the way, and then it can get out. Yeah.
Our second one was, in the summertime, is heat going into your house or out? And then the answer was, heat is coming into your house. It goes from hot to cold, not
So if you're wondering, like, which direction does the heat transfers into your house in the summer when it's hotter outside than in. Okay, and it transfers out of your house in the winter when it's going from warm inside to colder outside. So heat transfers, again, from hot to cold.
We still need a third one.
Oh, you need a third
Yeah.
one? You got a third one? Nope, we got two. All right, here's a. I got room somewhere. There we go. Let's just write it on my paper. I got room for it. All right. Here's the question 3. Why is not all energy converted to work? So up here they talked about it can't convert all the heat into mechanical energy. Mechanical energy is basically a fancy word for work. So why can't we convert all of the energy into work, or heat? Why can't we convert all the heat into work? And the answer for this is some heat. Yes, and into the other stuff is it changes temperature. Yeah, some heat always causes a temperature change. So some heat is going to cause the temperature to change. The internal energy is the way we think about it. Or go about doing something else. But you can't ever have something that's only going to do work. It's always going to have to do some sort of other process. All right. Clarifying.
For clarifying, the second law identifies the direction of energy transformation in a natural process. And then a heat engine is any device that uses heat as input and provides mechanical work as output.
Good. So, second law identifies the direction that things go, hot to cold. And a heat engine is anything that is going to transfer heat into work. Anything that does heat into work is a heat engine. So combustion engines are the best example of this. Anything that transfers heat into work is a heat engine. Now, it doesn't transfer all the heat into work because some of the heat goes into changing internal energy. Okay? Your engine gets hot and all of the engine gets hot. So some of the energy is changing the temperature on the engine parts. So it's not all getting turned into work. Yeah.
The more air you can cram into your engine, the faster it goes.
You can, yes, to an extent. I mean, that's part of the idea of having more pistons or having a larger engine. Yeah. You allow for more work to be done. Yep. All right, and the visual.
The heat going from high temperature to low temperature, and some heat using for work.
Good. So here's the high temperature reservoir. Here's the low temperature reservoir. The energy goes from high temp to low temp, and of that energy, some of it is turned into work. Some of it is turned into work. Most of it just transfers from high temp to low temp. Most of it just goes into energy change. But some of it goes into work done. Okay? When you burn coal at a power plant, you use it to heat up water. Okay? That water changes energy. It gains energy, changes temperature, and then that transfers through the turbine. As the steam rises, it spins this turbine, and that turbine does work. So it does work to move the turbine. Some of that work comes from that burning of the coal from the heat energy, but mostly what the heat energy does is it transfers its temperature to a low temperature area. So it heats up the air around it, heats up the water, heats up the steam. Okay? All right. Any questions on this one? All right.